You're listening to the N2K Space Network.
What's going on with LEO? Well, there's a lot going on with LEO, actually. There always is, but especially lately. In fact, LEO's been very busy with a host of new satellites coming soon. Earth observation NUVIEW's constellation will be amongst them, heading to LEO, aka low Earth orbit, thanks to Leo, aka Leonardo DiCaprio.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is June 6th, 2023. I'm Maria Varmazis, and this is T-minus. NUVIEW's new funding. A new contract from Space Systems Command for L3Harris. Thales Alenia and Serco seize their destiny. New Shepard launches to resume soonish. And what's just gone up to the ISS? Well, we're talking about it today with ISS expert and the inventor of the ISS-Above, Liam Kennedy. Stay with us. Let's take a look at what we have in the Intel briefing for today. With $1.2 billion in funding already in hand from early adopter agreements, Florida-based Earth observation company NUVIEW announced that they've got plans to make the world's first commercial light detection and ranging, or LiDar, satellite constellation. And they now have a new consortium of funders backing up these efforts, including aforementioned environmentalist and actor Leonardo DiCaprio. LiDAR, not Leo, offers advantages over traditional optical satellite imagery in that it can see through thick vegetation or clouds as well as at night. The planned LiDAR constellation from NUVIEW will have centimeter-level resolution, with plans to map the entire world's landmass in 3D annually. The technology will help researchers, governments, and enterprises that are focused on tracking and mitigating the effects of natural disasters and climate change. And aside from Leo, NUVIEW's investors include Mac Venture Capital, Broom Ventures, Cortado, Florida Funders, Industrious, Liquid 2, and Vito Capital. And if you're interested in a career with NUVIEW, they are recruiting, by the way. Go and check out the post by our friends at Evona on LinkedIn for more. U.S. Space Systems Command has awarded a nearly $29 million sensor payload design contract to L3Harris Technologies, making the company the third vendor for SSC's medium Earth orbit missile track custody program's Epoch 1 satellite constellation. SSC's program, which began as a demonstration, has since expanded, and the first delivery of the missile warning and tracking system, Epoch 1, is planned for the next 3 to 4 years. SSC's plans to deliver satellites every 3 years in epochs incrementally builds capability over time. The program aims to deliver the latest overhead persistent infrared sensing technology into an entirely new satellite constellation in MEO. Westinghouse Electric Company and Astrobotic have signed a Memorandum of Understanding to explore collaboration on space technology programs for NASA and the Department of Defense. The partnership is looking to develop space nuclear technology and delivery systems. Westinghouse is developing a scaled-down version of the 5-megawatt eVinci microreactor to power spacecraft in orbit or for deployment on the surface of planetary bodies such as the Moon or Mars, providing continuous power for space research and other applications. The MOU will also extend to strengthening the space nuclear supply chain and workforce in the Pennsylvania, Ohio, and West Virginia region. Thales Alenia Space has announced a partnership with Serco, the leader of the consortium awarded by the ESA, to implement the Destiny core service platform, known as DESP, a key part of the European Commission's flagship initiative, Destination Earth, known as Destiny. The Destiny program is developing digital models of the Earth to monitor and predict the interaction between natural phenomena and human activities, anticipate extreme events, and adapt policies to climate-related challenges. Thales Alenia Space will be responsible for the runtime orchestration platform setup, deployment, and operations, as well as all the cybersecurity management of the DESP framework. Space infrastructure services company Momentus has announced a contract with Italy's Apogeo Space to provide orbital transportation services for 9 of Apogeo's IoT constellation Pico satellites. The deal is the second 9-satellite batch that Momentus will deliver for Apogeo's planned 100-satellite constellation, which is scheduled to enter service by the second half of 2023. Apogeo Space is building a constellation of small sats that are capable of providing connectivity to Internet of Things or IoT devices across the globe. Apogeo CEO and founder Guido Paracenti said that the company anticipates full coverage will be achieved by 2027 with almost 100 satellites, with successive launches approximately every 3 months. And speaking of a regular cadence of launches, what's going on with Blue Origin? Well, speaking at the Financial Times' Investing in Space event, Blue Origin Chief Executive Bob Smith said the company is close to resuming New Shepard launches, pending approval from the FAA. New Shepard operations have been grounded since September last year when a cargo flight experienced an engine failure. Blue Origin announced in March that its investigation found that NS-23's flight engine failure was due to operational temperatures that exceeded the expected and analyzed values of the nozzle material. The New Shepard rocket launches from Blue Origin's facility in West Texas, carrying people and payloads above the Kármán line and back to the Texas desert. We will, of course, let you know when the FAA reviews Blue Origin's plans and allows those flights to resume. You can't escape China in the news at the moment, and that certainly continues into our daily briefing. Chinese scientists at the Shenzhen Institute of Advanced Technology at the Chinese Academy of Sciences say they've conducted a first-of-its-kind experiment to produce blood stem cells in space. The stem cells were brought back to Earth by the Shenzhou 15 spacecraft this weekend after being cultured for 15 days in the lab module of the Tiangong space station. After the completion of the experiment, China expects to become the first country to create early-stage blood stem cells in space, which is something that's being worked on in other countries as well. Russia's TASS news agency is reporting that the country's Luna 25 moonlander, which was due to launch on July 13th, has now been delayed until August at the earliest. Slips in launch schedules aren't exactly breaking news in the space industry, but we are all keenly watching this mission since it slipped in 2021. Lunar 25 is this country's first lunar expedition since the fall of the Soviet Union. Its predecessor mission, Luna 24, was conducted in 1976. Well, when one launch slips, another one comes back online. NASA released an independent review, which has concluded that the Psyche asteroid mission is back on track for a launch this October. The mission was delayed last year after experiencing software problems. The review also blamed issues at NASA's Jet Propulsion Lab, including a strained workforce and poor internal communications, as a cause of further delays. The Psyche mission plans to explore a unique metal-rich asteroid orbiting the Sun between Mars and Jupiter. NASA has set a launch date for October 5th this year, and we will absolutely keep an eye on that. And SpaceX's Dragon spacecraft successfully launched with the ISS earlier today for the 28th cargo resupply mission for NASA. The vehicle carried 7,000 pounds of cargo to the orbiting laboratory, to include some new solar arrays and some very interesting experiments that we will be discussing next in my chat with Liam Kennedy, ISS expert and inventor of ISS-Above. So definitely stay with us for that. And that's it for our briefing for today. Hey T-Minus crew, our audience is growing rapidly, and that is a big thanks to you. If you're just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. Also, do us a favor if you could. Please share your favorite episodes on social media. It helps professionals like you to find the show and join the crew. You can find our social media profiles in our show notes and at space.n2k.com. Our interview today is with Liam Kennedy, inventor of the ISS-Above, which is a neat little gadget, his words, not mine, that displays a whole batch of info about the space station when it's passing, who's up there, and also shows live views of the Earth from the space station. And I should also mention, Liam is an ISS expert, so we start the discussion today about what the SpaceX Dragon capsule took to the space station today.
CRS-28 from SpaceX is the cargo resupply mission. So over 7,000 pounds of resupplies, including science missions, CubeSats that will actually launch from the space station, and a whole bunch of experiments that are destined to be inside the station or hosted externally and perhaps put on through a spacewalk. And I think one of the most exciting things, if I was an astronaut on the space station, especially if I'm Frank Rubio and I'm headed to spending more than 1 year in space, one of the biggest highlights is the fact that they're sending up some fresh fruit.
Yes!
And cheese, apparently.
A little charcuterie board for the astronauts. It's great.
But yeah, so let me tell you a little bit about what I know about what is in the cargo mission beyond fruit, salad, and a bit of cheese. So there are two sections to the cargo resupply. There's the pressurized section and there's the unpressurized cargo hold. So in the unpressurized cargo hold, there are two IROSAs. That's the ISS rollout solar arrays.
Right,
and we've all been following, I think, the amazing development with the power generation equipment on the space station. There are already a bunch of IROSAs installed and fully functioning. And these are the two. They may be the final ones, although that would make only 6. But they really do have a very high power generation capacity, much more efficient than the existing set that are on there that are obviously getting more than 23 years old now. And they are supposed to be installed, at least one of them installed at the end of this week, I believe. June 9th is the actual spacewalk. So there's a bunch of other sort of housekeeping hardware pieces, upgrades to various systems, fixes to certain things. But then the bit that I'm most excited for are the experiments that are launching.
Yes, walk us through those.
Yeah, with what I do with the ISS-Above, that's in really thousands of schools in the USA, Canada, Europe, and other parts of the world. And what that means is that I'm keeping an eye on everything that's related to that would be of interest in the student realm. That's from K through 12 and beyond into university level as well. But mostly my focus is in that area. And that comes from me being an education partner with the ISS National Lab. And the ISS National Lab, they sort of control 50% of astronaut time for all experiment working on the ISS in the US side of things anyway. So there are a bunch of implementation partners that work with NASA and with the ISS National Lab, and they help organizations launch experiments to the space station. And most of those, their final destination is the space station. They'll remain there. But there's a growing demand for using the space station as a platform to launch other satellites, little tiny ones, called CubeSats. The organization that's developed that capability is a commercial organization called NanoRacks. And they have what's called a CubeSat deployer. This CubeSat deployer is taken out of the space station, really using the Japanese arm, the Kibo module. And then this thing has a mechanism to release and push away these CubeSats. Now, some of these CubeSats, they are built by educational institutions. They could be completely commercial organizations. In the past, the organization Planet that has, they call them flocks of Earth viewing satellites. Their very first flock Earth viewing satellites were launched by nanoracks on the space station. So a lot of what goes on the space station in terms of experiments are Earth viewing. So if we start off with those CubeSats, there's a couple that are worth mentioning related to the Canadian Space Agency. And they have a couple of CubeSats doing various different things. One of the ones that I'm particularly interested in is something called IRIS. And it's a partnership between all 5 major provinces of Canada. And it's being run through the universities in those regions, but also into high schools. So IRIS it's actually watching something called cosmic weathering. So they have some material on the outside of this CubeSat, and they'll have cameras that are monitoring what's going on with that. But here's the thing that really makes a difference for student-based experiments is the fact that this satellite is something that they manage and control. If you were to look at the project plan for any of these CubeSats, it's really a full-on satellite development project from soup to nuts. And what that does is any students who are involved in these projects gets exposed to everything it takes to put a satellite in space and to operate, maintain it, and get all of the data from it. The other one, called Essence, and like all good things that have anything to do with space, the acronym means something. It's Educational Space Science and Engineering CubeSat Experiment. This is a really cool thing because it carries a wide-angle camera, and it's designed to monitor the thawing of ice and permafrost in the Canadian Arctic. And the thing about this is, remember I said it gets launched from the space station. And these little CubeSats, they don't have the capacity to alter their orbit, drastically. So they pretty much will stay where the space station is roughly going, which means it's that the top of its orbit reaches to about 52 degrees in latitude north. So that means this CubeSat, this wide-angle camera, it's got to be pretty wide angle in order to look at something which is in the northern side of the Canadian Arctic. Because naturally, if it was a regular Earth viewing satellite, it would be pointing down at the Earth, and right below it, you don't see things like aurora and things like that with a camera pointed directly down. But you do, if you point it sideways, you will be able to see stuff over there.
And they can control the orientation, or is it just going to be kind of?
They can, or I'm not sure on on how they will be pointing this. It certainly has the capacity to actually alter its orientation. And typically on little CubeSats like this, they have little gimbals or gyroscopic type things that allow them to move it around, because these things have solar panels on them, on their little bodies that allow them to get powered nicely. But there's a bunch of other things on there as well, because you never want to put a CubeSat in space and it just only do one thing. It's got a solar energetic proton detector. These all sound really super, I say Star Trek-y, Star Wars things, don't they? I love them.
More advanced than anything I ever did in high school or middle school or whatever age these kids are. I'm always just so impressed by the level of sophistication. We were doing egg throws. It's just not the same. They're sending CubeSats. It's just incredible.
Yeah, isn't that amazing? And some of it is just simply knowing that that's possible. This sort of podcast, what you're doing is shining a light on these kinds of capabilities. And I know there's obviously very appropriately a very much commercial aspect to spaceflight. But in order for there to be that commercial spaceflight capability, you've got to have a very knowledgeable workplace. And that starts all the way in school. I mean, you mentioned it. Yeah, if you'd have, you were doing some cool things in school, but, in retrospect, you're thinking, yeah, wouldn't it be even cooler if you'd have been exposed to these kinds of things? And that's what this is all about for me, is getting that spark to ignite the younger minds into just understanding where they can go.
And Liam will be back with us tomorrow to tell us about a few of the other experiments that have just reached the ISS and about his ISS-Above system. We'll be right back. And welcome back. There's always something good coming from Webb, and this news today is no exception. The James Webb Space Telescope spotted polycyclic aromatic hydrocarbons in a distant galaxy, SPT 041847, don't ask me to read that one again, which is 12.3 billion light years away. Now, we do look for PAHs in galaxies, but this is the furthest away from Earth that these kinds of chemical compounds have ever been seen. So what are polycyclic aromatic hydrocarbons? Well, they are part of what make up what we know as soot or smoke, and they are often found near massive young stars, although astronomers aren't still entirely sure how they form. Now, the reason this discovery of these soot molecules is noteworthy is because of the distance involved. Because in the context of Webb, looking far away is also looking back in time. Now, spotting soot in a galaxy that far, far away and back in time means the universe was very busy making stars even in its earliest eons. All this cosmic star soot is star stuff, and all works into how stars and galaxies are formed. So these smoke signals from SPT 041847 invite a whole bunch of new questions and help us understand just a little bit more about our universe. All in a day's work for Dear Webb. And that's it for T-Minus for June 6th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. See you tomorrow.
T-minus.